Earlier in the course, we've been working with quadratics. Uh, we have worked with quadratics in three different forms. Each form gives us different information about the particular quadratic function or parabola, as they're called. The first method was called standard form, y equals ax squared plus bx plus c. From this form, all that we know is the direction of opening A and the y-intercept is C. Second form we learned was factored form, y equals A, and then in brackets x minus r times x minus s. We know the direction of opening A. The x-intercepts are zeros, which happen to be r and s. Third form was vertex form, which is y equals a x minus h quantity squared plus k. We know the direction of opening once again, and the coordinates of the vertex, which are h comma k. If a parabola opens down, the vertex represents a maximum point with a value of k. If the parabola opens up, the vertex represents a minimum point with a value of k. So what we do, the process to go from standard form to vertex form is a process called completing the square. From form 2, the factored form, we could use the zeros to determine the equation of the axis of symmetry. Of course, the vertex is on the equation of the axis of symmetry. So the axis of symmetry here it's x equals r plus s divided by 2. And once you have this x value, this is the x coordinate of the vertex, you could sub it back in to this equation to find the y value, which would be your y-coordinate of your vertex or your max or min value, depending on the direction of opening for your function. What do you do when you are posed with a quadratic question? Really depends on the words. So I'll give you an example. The height of a ball is h equals negative 5t squared minus 20t plus 40. What we do with this particular quadratic function depends on the questions that are being asked. First question is, what is the initial height of the ball? To determine this, we could simply plug in times 0. So we get h equals, obviously negative 5, 0 squared minus 20 times 0 plus 40. Of course, when you replace the values, the variable t with 0, the first and second terms become 0, so you just end up with 40. Always look back at the question to see what the units are, as you will lose marks if you don't include the units. Most likely, the units for height are probably meters, and the units for time are probably in seconds. Part B of the question would be, when does the ball hit the ground? Well, the ground is considered to be h equals 0. So we're going to replace the h with 0 here. So we're going to get 0 equals negative 5t squared minus 20t plus 40. Actually, I see a potential problem with my particular equation here, so we're going to make an adjustment now. I'm going to change the minus 20t to a plus 20t. And that will change this, but won't change the answer for part A because it was 20 times 0. But that's going to be plus 20. Of course, what we have come up with here is a quadratic equation. And of course, there's different ways that we can solve this. We could try factoring it, but that isn't always possible. But we could potentially use the quadratic formula, which will always work. So using that, the time is going to be equal to negative b, so negative 20, plus or minus the square root of b squared, subtract 4, a, which is negative 5, times c, all divided by 2 times negative 5. We got negative 20 now, plus or minus 20 squared is 400. And then what we're going to get here is going to be 4 times negative 5. That's negative 20 times 40 is negative 800. But because of that, it's going to be subtract negative 800, so it's going to be plus 800. And we're going to divide by negative 10. We got negative 20 now, plus or minus the square root of 1200. When we divide by negative 10. So this is going to give us two possibilities. T equals negative 20 plus the square root of 1200 divided by negative 10, or T equals negative 20 minus the square root of 1200 divided by negative 10. If you were to work this one out, you would get a negative answer, a negative time, which is not possible. So we work with this one, negative 20. So when we work this out on the calculator, we get, in the numerator, we get negative 54.64 divided by negative 10, which is going to be 5.464. So we should include a closing statement. Therefore, the ball hits the ground in 5.46 seconds. So the last part would be, what is the maximum height of the ball? So this will be part C. What is the maximum height of the ball? And when does it occur? So once again, our formula is h equals negative 5t squared plus 20t, I think that was the correction we made, plus 40. Just having a look back up here, just to check. Yep, that's what it was. Once again, whenever a quadratic question says most, maximum, minimum, we want to put this into vertex form. We group the first two terms. Next thing we want to do is we want to factor out the number that's in front of the t squared. So we're going to take out the negative 5. That's going to leave us with t squared. And we got to divide basically this by negative 5, and 20 divided by negative 5 is negative 4t plus 40. We want to put it in vertex form, so we need to create a perfect square trinomial here. So we need to take half of the negative 4, which is negative 2. So we'll do this off to the side. So there's negative 2. And we want to square it, which gives us 4. So we're going to take this 4, and we're going to add and subtract it inside the bracket. So negative 5, t squared minus 4t plus 4 minus 4 plus 40. Next thing we want to do is we want to keep the first 3 terms. But we want to remove this one from the bracket. But because the bracket is multiplied by negative 5, we need to do negative 5 times negative 4 to bring it out. So negative 5 times negative 4 is positive 20. Leave the trinomial in the bracket. As we said, it's going to be plus 20 plus 40, which simplifies to 60. This perfect square trinomial now, two numbers that add to negative 4 and multiply to positive 4, obviously that's negative 2 and negative 2, so if you factored this expression, it would be t minus 2 in one bracket, t minus 2 in the other. But we just write it like t minus 2 squared plus 60. So the vertex, if you were graphing this, would be at the point 2, 60. But to answer the question, the maximum height is 60, I think we said meters, and the ball reaches the maximum height in 2 seconds. Best wishes on your math exams.